Hello, good afternoon, everybody. We are ComScan Medical Systems Inc., and we have the pleasure to be here working hand to hand with United Imaging. Right now, are presenting the clinical specialists Andrea, Marcela, and Valeria.
So, for those patients that either experience claustrophobia or anxiety during PET scans, we come up with the innovative solution that focuses mainly on two improvements. The first one is improving greatly the image quality, and the second one is reducing the time of the study.
These enhancements are designed for to make process more comfortable for patients while ensuring accurate and efficient results. A PET scan or positron emission tomography is an advanced imaging technique used to diagnose and monitor conditions such as tumors, cardiovascular diseases, and neurological disorders. It involves administration of a radioactive tracer, typically FDG, a form of glucose that has been touched with a radioactive marker. This tracer accumulates in active tissues, emitting positrons that are detected by the scanner to produce detailed metabolic and functional images. To ensure optimal image quality, patients must remain immobile, maintain proper alignment in the scanner, and stay relaxed. Additionally, the environment is controlled to prevent shivering or muscle movement, which could introduce artifacts into the imaging results. Have you ever thought about how even the slightest movement, like breathing or shivering, can affect medical imaging? During a PET scan, this is a big deal. Any motion from the patient, even something as small as shivering because it's cold, can blur the images and make them harder to interpret. It's like trying to take a clear photo when your camera is shaking. So, how do we solve this? The key is finding those tiny moments when the body is completely still. If we can detect these perfectly still windows, we can capture clearer and more accurate images. Our approach combines advanced monitoring systems with ways to keep patients comfortable during the scan. This helps reduce movement, improving the quality of the images, and ultimately leading to better, more precise diagnosis. It's a game changer for PET scans. The goal of our system is to make sure everything is just right for a clear PET scan. To do this, our system tracks the patient's breathing and finds those moments when they are completely still perfect for taking clear images. It also keeps an eye on the patient's skin temperature. Why? Because staying warm helps prevent shivering, which could mess up the images. By doing these two simple things, the system helps make scans better and more reliable.
Now, let me introduce the development process of our electromyography system designed to monitor diaphragm activity during breathing. The first step was determining electrode placement. We chose two electrodes positioned over the diaphragm and a reference electrode placed at the hip stroke contours. Next, we designed the circuit for signal amplification using a bioinstrumentation amplifier. This was followed by implementing a high pass filter to eliminate input noise, a low pass filter to focus on frequencies of our interest, in our case was of 150 Hz, and finally a notch filter to remove the line noise. After filtration, we prepared the signal for the microcontroller by adding another amplification stage to boost the signal above 1 volt. Finally, to protect the microcontroller from electrical damage, we integrated an optocoupler for electrical isolation. After the electrodes captured the diaphragm's electrical activity, we preamplified the weak signals using a bioinstrumentation amplifier. The gain was set at 330 to prevent signal saturation, as the diaphragm's activity generates higher voltage outputs due to ion exchange because of the many glands located in this zone. The amplified signal then passed through the filtration stage previously mentioned. When analyzing the signal, we observed that during inhalation, the diaphragm contracts, resulting in higher amplitude signals with peak-to-peak voltages up to 240 millivolts. In contrast, during exhalation, the signal amplitude drops to around 120 millivolts, representing the diaphragm's rest state. Before processing, the signal underwent a final amplification stage to ensure it exceeds 1 volt for microcontroller compatibility. For example, signals as low as 110 millivolts were amplified to 1.46 volts, while signals of 240 millivolts were amplified to 3.18 volts using an average gain of 13.3.
The signals previously emitted by the electromyogram and that were filtered and amplified were handled specifically by an Arduino microcontroller. What this device did is that it compared them against a predefined threshold of 1.5 volts. Signals below this threshold indicated minimal muscular activity, and what this meant is that the diaphragm was on its resting state. To ensure effective communication with the technician, the system integrates a visual indicator. The diaphragm state is signaled through an LED connected to the Arduino. When the diaphragm is at rest, the Arduino outputs 5 volts, turning the LED on. This visual signal allows the technician to take the image during the PET, free from muscular activity associated with breathing. This way, we enhance the accuracy and quality of the scan. Finally, we've integrated a temperature monitoring feature using the DS18B20 digital sensor. This system measures the patient's body temperature in real time, ensuring it stays within the optimal range of 36 Celsius to 37.5 Celsius. The Arduino evaluates the temperature and displays either a correct temperature message or an alert if intervention is needed. This feature enhances patient safety and ensures stability during the PET scans. At CalmScan Medical Systems Inc., we prioritize the well being and comfort of our patients, particularly those who may experience anxiety or claustrophobia during medical procedures. We understand that the PET scan process can be daunting for many individuals, specifically for those who are unfamiliar with what to expect. To address these concerns, we are committed to implementing a series of enhancements to our respiratory and temperature monitoring system. Our goal is to create a supportive environment that alleviates anxiety and fosters a sense of security. By focusing on the patient education, comfort, and efficient imaging techniques, we aim to ensure a positive experience for all patients, making their journey through the PET scanning process as smooth and reassuring as possible. To enhance our respiratory and temperature monitoring system, we will implement four key strategies. First, we will conduct a pre scan assessment to help relax patients by thoroughly explaining the procedure and providing them with a card to comfortably store their personal belongings, and was designed by our team in Fusion 360. This approach aims to alleviate anxiety and create a more welcoming environment. Second, we will implement a solution to minimize lag during image capture, ensuring that the resulting pictures are as clear as possible while reducing the duration of the scan. Third, we will take two temperature measurements, one from the hand and the other one from the back of the ear. This dual approach is essential because we recognize that temperature ranges can differ between these areas, and extremities tend to cool down more quickly. By integrating these strategies, we aim to improve patient comfort and the overall quality of imaging results. To take into account the clinical specialist's individual focus, we have that Marcela contributed to the design and development of the motion detection system, enabling precise identification of minimal movement windows to ensure clear PET scan images. Valeria focused on the temperature monitoring system, integrating real time sensors to maintain stable body temperature and prevent motion caused by shivering. And Andrea optimized the system's signal processing, ensuring accurate real time analysis of breathing and temperature data for reliable imaging sources.